Assalamualaikum warahmatullahi wabarakatuh. Today we will discuss example number 10. Figure shows a horizontal flow of water through a slice gate, a hydraulic jump, and over 6 feet sharp crested weir. Channel, gate, jump, and weir are all at 8 feet wide unfinished concrete. Determine the flow rate, the normal depth, Y2, Y3, and Y4. So this is the figure of the open channel. So mean we have a dam here, and then we have a sluice gate, and then the water flow, and suddenly the level of water increase at certain height, and then it will go through the weir here. Okay, the sharp crested weir. So and then it will flow out like this one. So for this one, we will treat a little bit special. Okay, okay. Okay, now we will go for the solution for this one. We go for how to determine the flow rate of the slice gate like this one. So and then we already calculate the common equation for the flow rate for the weir, for the rectangular weir, as CDHB square root 2GY1. So we learned this in fluid mechanics 1. Okay, I hope you still remember how to mention of this one. But in this subject, I will give you all the notes later on if you need to calculate this in your final exam or your test. Okay, so in this situation, we have a condition where h over y1, which is less than 0.5. So let's say we have h is 3 feet and the y1 is 12 feet. So we get the ratio is 1 over 4, which is less than 1 over 2, mean less than 0.5. So we could calculate the value of CD according to this equation. So everything here is actually based on the notes, based on the note about the weir. So we substitute all the value here. So we get the CD is equal to 0.568. So we substitute the value of CD here into this one. So and then we could get that the flow rate is 379 feet cube per second. So again, I would like to remind you, if you use British unit, which is feet and inch, so please make sure that you use the correct value of gravity. So the gravity in British unit is 32.2 meter per second square. So and then we need to calculate the normal depth. So because this channel is horizontal, so we could assume that there is no normal depth. So usually the normal depth is actually when you have an inclined open channel. So that is the trick question. So and then we go for the Y2. Okay, so for Y2 here, so we have the Y2 still before the hydraulic jump, so means that it's still actually the energy is the same. So let's say we calculate the flow rate. Okay, from the calculation of flow rate, we know that the flow rate is 379. So we could calculate the flow rate for the location number 1. So we have 12 times 8, and then we have V1. So we could calculate the velocity of V1 is 3.95. So here for the calculation, it is okay for us to use the assumption of A1, B1 here because so and then we calculate the energy at point number 1. So we use the specific energy equation Y1 plus V1 squared over 2G. We substitute everything so we could calculate the value of E energy at point number 1 is 12.24 feet. So and then we calculate the flow rate. So based on the flow rate at point number 2, so we know that the flow rate is 379. Then we equal with the A times V. So the A is now, the width is 8. So the height of water is 2 and the velocity is V2. So we could have that. We cannot solve this one because we don't know, we still have two unknown parameter. So it is okay, we create another equation based on the energy equation here. So we have a y square plus v square over 2g, and it is equal to 12.24. So the value here is actually based on the energy at point number 1 here. So this is point number 1 and this is maybe here point number 2. So if we do this, okay, we have two equations right now, and then from these two equations, we could calculate the value of V1, and we could get the value of Y2 and V2. So, and then if we calculate both, so we could get Y2 is equal 1.83 feet, and the velocity at point 2 is 25.88 feet per second. Okay. So, and then we go for the Y3. So for Y3 here, according to the diagram here, we found that the Y3 here is after the hydraulic jump. So again, we could equalize, we could use the value of flow rate, the value of flow rate, but the value of energy cannot be equal, because if we have a hydraulic jump here, so means it will use certain amount of energy, so means that the energy at point number 3 will reduce. So because we have hydraulic jump, we use this equation. I hope you still remember this one, and then we could calculate the value of Y2 is 1.83. So and then from this calculation, and then we could calculate the float number, and then we could get it is 3.37. So means that it is true that the hydraulic jump was occur. So and then if we substitute everything, we could calculate that the y here is 7.85 feet. So and then we go for the y4. So for y4 here, we have, if we see the diagram here, so at y4 here, we want to calculate what happened in this one, whether it is here or the total one. So we will check the calculation later on. Okay, so and then we have a wear here, a thin plate wear or sharp crested wear. Okay, so and then the wear for the flow rate is CDB times G square, G square root G and H to the power of 3 over 2. So and then the CD for the thin wear or sharp crested wear, you could see this in the lecture notes. So it is equal to CD is equal 0.564 plus 0.0846 H over Y. So and then we need to calculate the H over Y. So we found, so and then the H4 here is the height from the wear. And then the y here is the height of the wear. So this is the height of water above the wear. So and then we substitute into the equation, and then we could get this equation. So from this equation, so we equalize with 379, because we know that even though the flow is after the hydraulic jump, okay, the flow rate is remain constant. So we use the try and error. So I use Excel to get this one. So the value of H4 it is equal to 5.53 feet. So and then if we substitute into this CD, so we found that the value of CD is 0.642. So and then we could calculate the value of Y4, which is 5.53 plus 6. So means 6 here, the height of the wear. So and then we add with the 5.53 the value that we get from the calculation.